Good afternoon to everyone. So, what is the last problem we solved in the previous class? Please tell.
Evaluate 0 to 1 x power m
Okay.
log 1 by x
Logarithm
power
by
n.
x power n dx. Okay.
Yes, sir.
Okay. Thank you for Chandra. So, please write the next problem. Evaluate integral 0 to infinity dx divided by 1 plus x power 4. Solution. Okay. So before going to the solution, just I am going to ask, what is a substitution? Can you predict the correct substitution? Can anyone tell what is the substitution, apt substitution for this problem? Just you can try.
So x is equal to r power 1 by 4, sir.
X is equal to
R power 1 by 4.
r power 1 by 4. Okay. Uh, okay. Any other substitution? Okay.
Sir, instead of r, we can take tan theta.
Okay. So, what is your substitution? Exactly. What is your substitution, Rahul?
X is equals to tan theta whole to the power 1 by 4.
By 4. Okay. So, what is x power 4?
X power 4 is tan square theta.
Tan theta.
Okay, tan theta.
Uh,
We should get x to the power 4 is equals to tan square theta.
okay. Is it correct? You are telling this one, huh?
Yes.
Uh,
No, sir.
no.
Sir, x is equal to tan power 1 by 2 theta, sir.
Oh, okay. I think that is Rahul also told. Is it correct, Rahul? I think you
Yes,
told
sir.
the same thing, huh?
Yes, sir.
Okay. Okay. I think both of them are coming to the very close to the answer. You are right. So, okay. So now I am going to take what is x power 4?
Tan
Now,
square theta.
tan square theta. So anyway, at least some of you replying for the question, okay, and also this is the correct substitution, okay. So because why I'm asking you, so if you know the correct, if you substitute the correct substitution, you will get the correct answer, okay. So if the substitution is wrong, then your final answer is also wrong, so you will not get the correct form. So in maximum in the integration, finding the substitution is an art, okay. And also you need to think about a little bit. You need to cleverly think, okay. So put x power 4 equal to tan square theta. Okay. So now from this x square equal to tan theta. So if you differentiate with respect to theta, you'll get what? 2x dx 2x dx is equal to secant square theta into d theta. Okay, I need a dx. Okay, so dx is equal to secant square theta into d theta divided by 2 into x. But I need to write x in terms of what? Theta. So from this, what is x? X is equal to
tan,
root of
tan
tan theta. So 2, I need to write x, but instead of x, I can write what? Root of tan theta. Okay. So I know what is dx. I know what is x power 4, everything in terms of theta. Still, what is remaining? Still, what is remaining?
We have to convert the limits, sir.
Very good. Very good, Rahul. We need to convert the limits. So when x is equal to 0, okay, when x is equal to 0, I am substituting here. Okay, 0 is equal to tan theta. 0 equal to tan theta. So this implies that theta equal to 0. So when x is equal to 0, theta equal to 0. So next, when x is equal to infinity, substitute x is equal to infinity here. So theta, infinity equal to tan theta. This implies that theta should be pi by 2. So the I, this is I. What is I? I is equal to integral 0 to infinity dx by 1 plus x power 4. 1 plus x power 4. So that is equal to, now everything in terms of theta. So theta varies from 0 to pi by 2. 0 to pi by 2. Okay. Dx is equal to what? Secant square theta into d theta divided by 2 into root of tan theta. Okay, this is okay. I think I wrote dx and then 1 plus x power 4. 1 plus x power 4 is what? 1 plus tan square theta. 1 plus tan square theta is
secant square theta.
secant square theta. I will write directly secant square theta. So secant square theta get cancelled. Okay. So now remaining is what? 1 by 2. 1 by 2 integral 0 to pi by 2. Okay. D theta divided by root of tan theta. If I write in the numerator, it is what? Root of cot theta into d theta. So 1 by 2 into what is this value? Anybody?
Pi by root 2, sir.
Very good, Ram. Pi by root. Yesterday, we solved this problem in the classroom. Okay, so please verify yesterday class notes. Integral 0 to pi by 2 root of cot theta d theta equal to pi by root. Okay, since okay. Second problem, prove that integral 0 to 1 x dx divided by root of 1 minus x power 5. Okay, root of 1 minus x power 5 is equal to 1 by 5 into beta of the final answer in terms of beta 1 by 2 comma 2 by 5. So now the solution. So please tell what is the substitution for this problem. So just you can try. I will help you. Okay.
Sir, x power 5 equals to sine square theta.
That's all. Very good, Raghu. X power 5 equal to sine square theta. Okay. Suppose if you don't, anyone don't give the answer, the next hint is, I want to eliminate this root. Okay. So you should think like this. I want to eliminate this root. When we can eliminate the root? 1 minus sine square theta. 1 minus sine square theta is cos square theta. Then you can eliminate the root. Even you can write x power 5 equal to cos square theta. 1 minus cos square theta equal to sine square theta. Then you can easily eliminate the root. So the problem is, first you need to eliminate the root here. So this is the idea. Okay. So I don't tell to Rahul or Purnachandra, okay, before this class. Okay, they are they think and then they'll reply. Okay, so that intuition. Okay, usually you need some intuitions. Okay, for each and every subjects. So that intuition sometimes will give the correct answer. Sometimes it don't give the correct answer. But without intuition, it is very difficult to solve the problems in integration. Okay. Now, substitution x power 5 equal to sine square theta. So this implies x is equal to sine power 2 by 5 theta.
Sir, we can write x power 5 is equal to cos square theta also, no, sir?
Yeah, yes, you can take cos square theta also, you can take Purnachandra. So your final answer is same. You'll get the same answer. That you can try later. Okay. So dx is equal to, differentiate with respect to theta, 2 by 5 sine power 2 by 5 minus 1. 2 by 5 minus 1 is what? Minus 3 by 5. Theta into, if you differentiate sine theta, you'll get cos theta into d theta. So this is dx. And I need to find out limits. Okay, well, limits. Then x is equal to 0, x is equal to 0, 0 equal to sine theta, 0 equal to sine theta. So this implies theta equal to 0. Similarly, when x is equal to 1, 1 equal to sine theta. So this implies theta equal to pi by 2. Okay. So now this is I. So I is equal to the given problem is integral 0 to 1 x dx divided by root of 1 minus x power 5. So this is the given problem. So now theta varies from where to where? Theta varies from 0 to pi by 2. Okay. X dx. What is x? X is sine power 2 by 5 theta. Okay. And dx. What is dx? Dx is 2. I want to write this one. Okay. Please tell. I will write into 2 by 5 sine power minus 3 by 5 theta into cos theta into d theta. The denominator, you have what? Root of 1 minus x power 5. I think the substitution is sine square theta. So now this is actually what? Cos square theta under the root cos theta. So cos theta gets cancelled. So remaining you have 2 by 5 integral 0 to pi by 2 sine power. If I add these two powers, sine power minus 1 by 5 theta into cos theta, but the cos theta is cancelled. Is it correct? Okay, but anyway, I am going to write cos power 0 theta because I need in the form of a beta function. That's why I wrote here. So, okay. So now this is equal to 1 by 5. Okay, 1 by 5 into 2 into integral 0 to pi by 2 sine power minus 1 by 5 theta into cos power 0 theta. So I think we know beta function in terms of what? If you see this integral, you should know beta function in terms of what? Beta function in terms
Circular.
of circular function. Very good point. Beta function in terms of circular function. So what is the beta function in terms of circular function? I will write here. Beta of m comma n, okay, is equal to twice integral 0 to pi by 2 sine power 2m minus 1 theta into cos power 2n minus 1 theta. Okay. So actually, this is beta function in terms of circular function. So 2m minus 1 equal to minus 1 by 5. 2n minus 1 equal to 0. Okay. And 2n minus 1 is equal to 0. So from this we have what is m? 2m equal to, you have 4 by 5. Okay, 4 by 5, 2m. So 2 by 5, m equal to 2 by 5. Okay, and from this n equal to 1 by 2. So I, actually this is also I. Okay, I is equal to 1 by 5. So please tell what is the next step. I equal to 1 by 5. Please tell.
Beta of 2,
Beta of
2 by 5.
m is 2 by 5. Okay,
Yes, sir. 2 by 5.
2 by 5, comma
1 by 2.
1 by 2. It's correct.
Like,
Correct, Purnachandra.
you
Okay,
can
actually
interchange.
this is what we need. Is it correct?
Sir,
Please check
interchange
the. Sorry,
beta of 1 by 2, comma 2 by 5, sir.
m is what? M is 2 by 5. N
Yes,
is 1
sir.
by 2. I
Yes,
think
sir.
this is correct.
Sir, but we can interchange m and n also.
Yeah. Yes. But okay. But okay, I got it. So in the question, it is like this. Okay. So, or x dx by root of 1 minus x power 5 is equal to 1 by 5 beta of 1 by 2 comma, because it's a symmetrical about its argument. Okay. Suppose the question is like this. Instead of prove that, evaluate this integral. Okay, then you need to simplify one more step. So what is the step? You need to write the relationship between beta and gamma function. Is it correct? I think this is enough. Suppose if they ask evaluate 1 by 5 gamma of what? 1 by 2 gamma of 2 by 5. If you add these two, you'll get what? 1 by 2 plus 2 by 5. So this is equal to gamma of half equal to root pi by 5. Okay, root pi by 5. This is gamma of 2 by 5. This is 10, 10, 5 plus 4, 9 by 10. Gamma of 9 by 10. So you can write two more steps. Okay, if they ask evaluate. Otherwise, suppose if they ask evaluate, here also there is no need to write cos power 0 theta d theta. 2 by 5 integration 0 to pi by 2 sine power minus 1 by 5 theta into d theta. I think we have the yesterday I think we derived the formula for integration 0 to
Yes,
pi by,
sir.
yeah, sine power p theta,
P theta.
sine power p theta d theta is equal to what? Anybody?
Root pi by 2
Hmm.
into root and p plus 1 by 2 by
Gamma
p
of
plus.
p plus 1
Yes, sir. Gamma of p plus 1 by 2
by
by
gamma
gamma of
of
p plus 2 by 2.
uh, uh. So you can also use that formula. Suppose if they ask evaluate, but the final answer is in terms of beta function. That's why I keep cos term here. Okay, cos power 0. Otherwise, there is no need to keep this one. Third problem. So third problem is that actually this is a two more question. So find integral 0 to infinity x power m minus 1 minus x power n minus 1 divided by 1 plus x whole power m plus n into dx. Okay. Now, solution. Okay. integral 0 to infinity x power m minus 1 minus x power n minus 1 by 1 plus x whole power m plus n. So please tell how to proceed the next step. If you know, you can tell.
Sir, we can divide x power m minus 1 by 1
Ah,
plus x whole power m plus n minus
that is, you are splitting the function.
splitting,
Huh?
sir.
Yeah,
Yes,
splitting.
sir.
Yes, okay. Okay. 1 plus x, okay, whole power m plus n dx minus 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. Okay. So what is the next step? What is the next step?
Sir, beta of m comma n, sir.
Which one?
First term, sir.
First term is
First,
what?
yeah, beta of n comma n, sir.
Okay, very good. What is second one?
Beta of m comma n.
Very good. Actually, I gave only this. Is it correct? The second one.
Yes,
Beta
sir.
function in terms of what?
M comma n.
No, I gave I gave a name for this integral. Beta function in terms of
Infinite integral.
very good, Paritosh. So I'm asking a question from the my what I take in the previous class. Okay, wow. So you need to go through the subject. Okay. So actually, I gave a beta function in terms of infinite integral. That is beta of m comma n equal to integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. Okay, but I don't tell this. So once you know these two are equal, okay, so you automatically show you should tell this is nothing but what beta of n comma 1. But Purnachandra told that. Okay, so the final answer is 0 because we know that beta function is symmetrical about its argument. This is equal to 0. We go to the next problem. Prove that beta of m comma n equal to integral
Sir,
0.
sir,
Sorry?
in last problem, can you write as 0, sir?
Yeah,
Okay,
0.
okay, sir.
That's all, over. Because these two are equal. We know that beta function is symmetrical about its argument. So beta of m comma n is same as what? Beta of n comma m. So otherwise you can write one more step. Okay, and then this is equal to 0. Okay. So next problem, prove that beta of m comma n equal to integral 0 to 1 x power n minus 1 plus x power m minus 1 divided by 1 plus x whole power m plus n into dx. So actually this problem is more or less very similar to the previous problem. But the only thing is you have the limit what here? 0 to infinity, here 0 to 1. Okay, here you have minus sign, here you have plus sign. Okay, but these two problems is entirely different problem. Solution. Okay. So now I am going to start from the known result. Okay, the known result is we know that beta of m comma n, beta function in terms of infinite integral is integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n dx. Okay. So already we know this result. Okay. So now left hand side is beta of m comma n. I am going to split this integral from 0 to 1. Okay, because I need 0 to 1, the final answer. So that's why I'm going to write 0 to infinity is 0 to 1 and then 1 to infinity. So 0 to 1, the integrand is same, x power n minus 1 divided by 1 plus x whole power, please write. Okay, so this is the given problem. We know beta of n comma n equal to beta function in terms of infinite integral. Okay, so now I'm splitting the integral 0 to infinity, so 0 to 1, the same integrand. So power is what? M plus n dx plus 1 to infinity x power n minus 1 by 1 plus x whole power m plus n dx. Okay, so now please if you listen carefully, okay, if you see here this portion is very similar to this portion. Okay, so only thing I want to show that the second integral is what? 1 to infinity x power n minus 1 by 1 plus x whole power m plus n dx is equal to integral 0 to 1 x power m minus 1 1 plus x whole power n plus 1 dx. So you should keep in this mind. So I want to prove this second integral equal to the second part of this integral. Then the problem is over. Okay. So now you should give the substitution. Okay, you should give a substitution only for the second integral because I don't want to change the first one. Okay, so so how your substitution will give 0 is mapped into 1 and 1 is mapping into infinity. So in such a way that you should choose x. So which x is equal to what? Now the question, x is equal to, what is x?
Sir, x is equal to 1.
Uh,
x minus 1 is equal to 0, sir.
X minus 1 equal to 0. No. If I substitute, no, I think you should use another variable. You should use the another variable. I think suppose in the interview they give this integral. Integral is 1 to infinity x power n minus 1 by 1 plus x whole power n plus n dx. Okay. So your limit, okay, when you substitute, okay, x value 0, it should go to 1. 1 goes to infinity. So then what is the substitution? So that is your question. Now, sorry, x is equal to, sorry, x is 0 na 1, okay, infinity, sorry. Here it is, yeah, okay. Sorry, please wait, please wait. So the substitution should give you, 1 should goes to, this 1 should goes to, it's a little bit tricky to predict. Okay, okay, I will tell you. But if you look at the limits, 1 infinity 0 1, I will give you 1 more minute time. Okay, so please try. So look at the limits 1 and infinity, but I need 0 to 1 or 1 to 0, whatever it may be.
Sir, x equals to 1 by y.
Very good, Rahul. Okay, so even I tried to explain, okay, but you got it. Okay, so very good. X is equal to 1 by y. The reason is, okay, if I substitute, okay, you can easily understand when I am explaining x is equal to 1 by y. So in the second integral, I am going to substitute, put x is equal to 1 by y. Okay. So now what is dx? Dx is equal to minus 1 by y square into dy. Okay. Now, from this y equal to what? Y equal to 1 by x. When x is equal to 1, what is y? Y is also 1. When x is equal to infinity, what is y? When x is equal to infinity, 1 by infinity, y is 0. So you may think 1 to 0. I have 0 to 1. But because of this minus sign, the limit will interchange. Okay. So that's why I told that 1 to infinity, okay, your substitution should give either 0 to 1 or 1 to 0. But here 1 to 0. Okay. So now I'll go to the next page. Okay, I'll write beta of m comma n is equal to integral 0 to 1 x power n minus 1 divided by 1 plus x whole power n plus n dx. Okay, plus from 1 to infinity. 1 to infinity means 1 to 0. Okay, here y varies from 1 to 0. Here x. Okay. What is x power n minus 1? X is equal to 1 by y. So 1 by y whole power n minus 1. Okay. And then dx. What is dx? Minus 1 by y square into dy. Divided by 1 plus x whole power n plus n. 1 plus x is equal to 1 by y. So 1 plus 1 by y whole power n plus n. Okay. So first integral, there is no change in the first integral 0 to 1. Okay, x power n minus 1 divided by 1 plus x whole power n plus n into dx. Because of this minus sign, you can interchange the limits. The limit is from where to where now? Y equal to 0 to 1. Okay, y equal to 0 to 1. And then actually, okay, first I will write this. The denominator you have what? Denominator y plus 1 by y whole power m plus n. This y power m plus 1 goes to the numerator. Okay. Otherwise, I will write first the numerator dy. Okay, I'll write this step by step. Dy. What is y power? Y power n minus 1 plus 2. N minus 1 plus 2. Here 1 plus y or y plus 1 or y plus 1 by y whole power m plus n. Okay. So the next step, I am going to write integral 0 to 1. Suppose if I done any mistake, please point out quickly. Denominator is 1 plus x whole power m plus n into dx plus integral 0 to 1. This y is going to the numerator, so y power m plus n in the numerator into dy. The denominator you have y power n plus 1 into 1 plus y or y plus 1 plus y whole power m plus n. So if you cancel these two terms, remaining you have what? Y power m minus n. Y power m minus 1 by 1 plus y whole power m plus n. Okay, I will write in the next page. Integral 0 to 1 x power n minus 1 dx divided by 1 plus x whole power m plus n plus integral 0 to 1 y power m minus 1 into dy divided by 1 plus y whole power n plus n. Okay. But here, instead of this y, I can, because this y is a dummy variable, even if you write instead of y, you can z power m minus 1 to dz by 1 plus z whole power m plus n, you will get the same answer. Okay. So that's why I am going to write what? So any guess?
X power m minus 1.
Very good. X power m minus 1 into dx divided by 1 plus x if I write like this, the students will ask, what question, Purnachandra?
Sir, substitution variable is different, sir.
Actually
We
they
have
will
taken
ask
x is
y
equal
equal
to
to 1 by x. We gave, sir, but you replaced y equal to x. But here it's not it's not in this sense. Okay, the sense we are just replaced by because of dummy variable. Okay, that means even you can replace this is by z. Z power m minus 1 to dz by 1 plus z whole power m plus 1, or t power instead of x we can use t. Okay, so the reason is since y is a dummy variable. Since y is a dummy variable. Okay, now what is the next step? What is the next step?
sir beta of m.
One more step. Okay, you can write, is it correct?
Yes, sir.
Okay, the denominator is same, 1 plus x whole power. Okay, the numerator is different, but the denominator is same. The integral is also same. Okay, that's why I can add the numerator and then I write. What is the left hand side? Beta of m comma n. I think I need to prove this. So you can please check it. So I want to prove beta of m comma n equal to 0 to 1 x power n minus 1 plus x power n minus 1 by 1 plus x whole power n plus 1 dx. The crucial idea is, this is the crucial idea. First, you should know beta function in terms of infinite integral, and then you need to split 0 to infinity is 0 to 1 and 1 to infinity. This is the second idea. Third one, very important one, in the second integral, you need to substitute x is equal to 1 by y. So only these three things you need to remember in your mind. So then you can solve this problem. Okay. The next is not a problem. Actually, this is a formula, but this is also sometimes we consider it's a problem. Okay. Okay, I'll put a problem 5. Problem 5. So we call this is a duplication formula. Duplication formula. Okay. Can't finish this problem. Still, I have only 5 minutes. So I will choose some other problem because I will take this problem tomorrow. I'll choose a simple problem. Yes, through that beta of m plus 1 comma n by m is equal to beta of m comma n plus 1 by n is equal to beta of m comma n divided by m plus n. Okay. So now here I am going to use two results. One is the relationship between beta and gamma function is beta of m comma n equal to gamma of n by gamma of m plus n. Okay. And second result, I am going to use the recurrence relation for gamma function. Gamma of n plus 1 equal to n into gamma of n. So if you know these two results, you can prove this result. Okay. So first I will take the numerator, that is beta of m plus 1 comma n. Otherwise, instead of m, replace by m plus 1. Beta of m plus 1 comma n, that is here. Okay. So using this result, you can write what? Gamma of m plus 1 into gamma of n, denominator gamma of m plus 1 plus m. This is equal to, so please tell, using this recurrence relation, please tell what is the numerator?
M into gamma of m.
Yeah, m into gamma of m. Okay, into gamma of n. Okay, denominator. What is the denominator? Again, use this recurrence relation. M plus n plus 1.
M plus n into
M plus n into
gamma of m plus n.
yes, correct, Purachitra. Okay, I need the denominator. I have m, so I will write this m here. Okay, so beta of m plus 1 comma n by m is equal to remaining is what? This portion is what? This portion is what?
Beta
Beta
of m comma n.
m comma n. This portion. Okay. So beta of m comma n divided by what?
M plus n.
M plus n. Okay. I call this is equation 1. Similarly, beta of m comma n plus 1. Please tell anyone how to write. The same
Gamma
idea. Gamma of
m
m
into gamma of n plus 1 by
gamma of n plus 1 divided by
m plus gamma of m plus
gamma of m plus
n plus 1.
n plus 1. Okay. So numerator. How to write the numerator?
Gamma of m
Gamma of m
into n into gamma of n
into gamma of n divided by
m plus n into
m plus n into
gamma of m plus n.
gamma of m plus n. Okay. So you can check here. The denominator I have n. So I will write, I am dividing by n. If I divide by n, both sides, n is equal to 1 by m plus n into gamma of n by gamma of m plus n. So from this we have beta of m comma n plus 1 divided by n is equal to you know that this is beta of m comma n divided by m plus n. I call this is 2. From 1 and 2, the right hand side of 1 and 2 are same. So and hence the left hand side is also same. Okay. So from 1 and 2, we get the required result. I think I will write, please check it. Beta of m plus 1 comma n by m is equal to beta of m comma n plus 1 by n is equal to beta of m comma n divided by m plus n. This is the required final answer. Proof is over. Sometimes they will ask in the question also beta of m plus 1 comma n plus beta of m comma n plus 1. So what is this one? This is equal to what? m into beta of m comma n divided by m plus n plus beta of m comma n plus 1 equal to n into the same thing, beta of m comma n by m plus n. So if what is common? Beta of m comma n is common, and also m plus n is also common. Remaining is what? M plus n. So m plus n gets cancelled. So I have beta of m comma n. So sometimes they will ask prove that beta of m plus n comma n plus beta of m comma n plus 1 equal to beta of m comma n. Okay, you should write these two terms here. So that's all. Okay, and I want to tell one more thing. Please write. Yesterday I sent a book, okay, Veerarajan book for integration. In your free time, so please try to solve the problems from this book. I sent this book. So the multiple intervals. So please go through this part. Okay, start from here. Okay, gamma and beta functions. 4.9. Just you can go through the basics. So if you study in the book, you can get more idea. Okay, suppose if you don't understand, and then you can watch my video and watch my PDF. So you should have a habit of reading the books. It's a recurrence formula. Okay, and gamma of half equal to root pi. This is a symmetric form of beta function. Trigonometric form. Okay, here this is a trigonometric form. Beta of m comma n equal to twice integral 0 to pi by 2. Okay, relationship between beta and gamma function. Okay, and then the example problems. So please first you should work out the example problems. So in beta gamma function. Okay, once you solved example problem, usually I will give assignment in the exercise problem. Okay, so exercise problem you need to solve 50% of problem. So in section you can start, even now you can start in section 4D, exercise 4D. Maybe I will give next week this assignment, but if you are ready, okay, you can solve it. Okay, at least 50% of your problems in part A. I think you have what? How many problems you have? 22, 11 problems. Similarly, you can part B also 50% of your problems. You can solve in your free time. Once I post the assignment, you can just take the photocopy and then you can upload in the GCR. So remaining 50% of the problem before the examination you can do. That is up to your interest. Yes, at least you should know 50% of your problem. Okay, so that's why I want to tell you, because you need to read the books, okay, especially this book. Okay, thank you. Okay, thank you, Gogol. Thank you, Avantika.